Hello, everyone. Thanks for being here today. As usual, we're gonna wait a few more minutes to give a chance to latecomers to arrive, and we'll start 5 minutes from now.
Hello, Pascal. Hello, everyone.
Hello, Alex.
Hi, all. We'll be starting in a minute. So it is 5 minutes past the hour. So I think it's a good time to get started. So hello, everyone. Very nice to see you here. It's our first interim since the summer, and we'll have only two before the next IETF. And we have very interesting topics for you for today. But just to get started, so this is an official IETF meeting, and as such, all IETF policies apply. So normally all of you already know the Note well, but just for the sake of procedure, you know that as a reminder, by participating in the IETF, you agree to follow IETF processes and policies. If you are aware that any IETF contribution is covered by patents or patent applications that are owned and controlled by you or your sponsor, you must disclose that fact or not participate in the discussion. And as a participant, you acknowledge that written audio, video, and photographic records of meetings may be made public. Of course, I'm not going to read the rest of it. I'll be respectful to each other, and of course, you need to read like to be aware of all the full BCP documents that are listed in the note well. Now, this being said, we have an interesting agenda for today. So there are 3 topics to be discussed. We have first in our agenda, we have Bob that is supposed to talk about SCHC protocol numbers, but I'm not sure if he's connected, so probably we can move. Yes, Jaime?
Seeing the agenda, Alex, would it be possible to bump us up at the beginning, or because I need to leave a bit earlier, if possible?
Well, actually, it's a good point. So Bob is not here, so you can start. You can do the first presentation, and then we'll have SCHC over direct to satellite IoT, and so it's Sandra that's going to be presenting today. And so at the end we'll have Bob, if he connects, that he's going to talk about the new version of the SCHC protocol numbers draft. Anyone want to add any point to this? No. So yes, and Eric, thank you very much. So the minute taker. So I will be taking some minutes, but if you can help us with taking the minutes, please say so. Let me go back here. So I'll be taking the minutes, Eric, and you know, I'm counting on the people in the group to be lending a hand. So. Oh, what's happening? Yes. Okay. So with this, okay, how do I close this one? Okay, I clicked somewhere and yes, thank you. Okay, zoom in. So with this, I just wanted to do a short reminder of the working group documents that and their state. So we have a new version of the SCHC protocol numbers, and that's really great news because it was stuck for quite some time. I know that Pascal was waiting for Bob to know if he's going to continue to work on the document or not. And Bob is continuing to work, so that's great. And hopefully he'll connect by the end of the meeting and tell us more about it. So the other documents are advancing. So I don't see any particular anything more particular in them. So we have a couple of new drafts. We have the SCHC over DTS IoT, which we'll see today, and we have the SCHC payload compression that we'll see today. So that's great news. And yes, we need to continue working on the working group items. So that's all from me. If you don't have anything else to add, then I'll give the word to. So Jaime, is it? I'm not sure who's going to be presenting. If it's going to be
presenting on behalf of the others.
Okay, great. So let me give you then the hand. Okay, so you have the control.
Yes. Okay. So I hope you can hear me well. So today I'll be presenting on behalf of the team the draft that is now an individual submission. So this is an early stages draft and everything is open for discussion, obviously. And it's about payload compression. So yeah, how can we use SCHC for payload compression? And we propose in the draft 2 mechanisms, and the idea is to reuse the SCHC engine, so the RFC 8724, but not just for headers, but also for compressing application payload. So, of course, you have also CBOR in this space, and there's dictionaries that can be used. So that's why actually this draft would merit some discussion on how to do it. We have 2 proposed approaches. One is a static, template-based static method for time series type of payloads, so things like JSON or SNML, and basically you will be using the template relative to the value as it changes, so it assumes some periodicity. And then the second one is the dynamic method for unknown payloads. So this one is a bit different. So the idea here is that you have a dynamic method that learns key values and generate the SCHC rules on the fly, depending on the payload of the series of payloads. Sorry. Next, just a second. So let's start with the static one. And the static one, basically, we would start with, as an example, with a device that periodically sends, for instance, NML records. And in this example, you have temperature and humidity. And instead of sending the full JSON every time, we define a template rule where only the residue values vary. And there you have, for instance, the placeholders. So on the right side, you have the template, and you have the placeholders with the values with $1 and $2 for those fields. And then basically when you apply decompression, it applies on the template. So it applies the template, and the 2 residue values are added to rebuild the original pack. Then when the number of measurements vary, we can use other keys like repeat, which is not shown in here, to describe a pair. For example, you can also have a shared timestamp, and you have the residue could be a sequence of triplets. It's not in this example, but what we have in this example is, for instance, the relative basis. So you have there the rel value, and so those are annotated placeholders. So they use semantic basis. So that would be one, the rel value, but you can have also, for example, relative time, like top of the hour or things like that, or relative context, so that only the offsets are sent. And this static approach is pretty straightforward. These are the mappings to the SCHC context. I am not a very strong SCHC buff, so sorry if there is something wrong here. I think it should be correct because I checked with the co-authors. But basically, you would have this, the SCHC definitions would be for the field identifier, you'll have a new structured app data to signal the payload compression. For the field length, you will have bit length, and if providing that all residue values share the same length, and they will be otherwise 0. Then you have the field position, which is 1 as default. Then the usual direction, which to my understanding is upstream, downstream, and bidirectional. And then the target value, which is the template itself. And then matching operator, and then the compression and decompression action. So on the compression decompression action, the decompressor will be, so the compressor sends the residues, and the decompressor will reconstruct using the placeholders. And that's high level, the static one. And then on the dynamic one, sorry, something happened. Just a second. On the dynamic one, it's a bit different. So on the top right, you have the process, which is is dynamic. So a priori, the server doesn't know the rules to be applied. So basically, it will be listening for data for payloads, and the process will involve 3 phases. First one is as payloads come, there will be a payload analysis, so that the compressor will inspect incoming SNML or JSON payload or other kind of payload. It's not tied to a specific serialization. And it will build a structure, so a map or a list, tracking the keys and the values. Then there will be a field selection. So based on the history, it would decide which key value fields are stable or repetitive enough to benefit from compression. So maybe like some parameters could be like the keys are seen very often, or the length of the keys, or others. And then in the third step, you will have the SCHC context and the rules generation. So the decompressor, so the server side, produces the SCHC rules targeting the selected fields, which the compressor can then apply to shrink future payload. So what you have there in the image is actually like in the top right of the screen is the actual setup after which the normal rules are applied. So it's like the dynamic process by which the rules will be generated for that particular communication. And then in the next slide, if I manage to click here, all right. So you have the example of how it would look like after checking the payloads and generating the rule map. So in this case, the payload has generated 3 rules that apply for this particular conversation or communicate. I don't know, maybe the term is not conversation, sorry, like the sequence of messages of payloads. The first rule is for the base name, the second for the temperature, and the third one for the humidity. And then basically, yeah, the parameters will be the first one uses the CDA not send, so it's only stable values, and the second one has the changing values that are sent based on the payloads of temperature, and the third one similarly for humidity. So the encoded payload will be much smaller as is expected, and yeah, so the in this context, basically you will be keeping a compression map on both sides after the dynamic generation, and providing that the payloads are continue being similar, I guess. Like otherwise, you can periodically adjust and generate a new rule set. So that's more or less it. And then the last item I have here. So I am aware, for instance, we are aware that there is Acleos SCHC template on the portal. In the news, I forgot to update the slides, but I have it on the slides in my screen. So we are aware of that one. So we assume that maybe the domain is of interest, the topic of payload compression. At this point, maybe we want feedback. And of course, like just to remember that it's not a header anymore. We are talking about payloads. So there is other things that do payload compression, and that we need to be, very careful about all of this. And that's why we would need a bit of discussion, I guess. That's it. Did I miss Edgar? Is it okay? Okay, I think we are good here. That's it.
Thank you very much. Thank you very much, Heimer. Very interesting. Yes, like the first reaction is, of course, that the payload is, the payload you're discussing, of course, it can be seen as the header of something else, right? So, in the end, the data is encapsulated in the things that your SNML is carrying around. So it's some kind of a header. But in any case, personally, I feel that it's a very interesting contribution. Yes, so I see that there are people coming, so I'll give the word to them and then get back. So Javier.
Yes, do you hear me now? Okay. So yeah, it's so just answering your first question. It's a proposed idea appealing for the workgroup. So I think it has its time and place. However, I've seen this a bit before. There's a thing called Dixie. I'm not sure if you've seen it before. We saw it in a demo a couple last year. Well, I'm not sure when it was published, but I saw it in a demo last year. And yeah, they do something like this. So I think there's definitely an interest. And my second answer or question would be if so I think your both approaches can coexist. So eventually there's like I think if I understood correctly, you have a static approach and a dynamic approach, and the dynamic would make a bit more like raise a bit more challenges, like how to share the context, like how to send the update basically. So I think both can coexist. And concerning the dynamic, so for example, how to exchange the updated context, right now we're working on precisely this, like in SCHC management. There's a SCHC management draft by Toutain. So not sure if you've also checked that out. Please, if you have any questions or if you see how this applies to payload compression, let us know. And so on. So I'm not sure if, yeah, that's for myself. Yeah. Thanks.
Okay, thanks. Maybe to answer like first, so you mentioned the demo last year, right? DT, I understood. I'm not aware, so if you could share the link somewhere, that'd be great. And then on the draft, Dixie, thank you. So if you have a link for it, I would love to check. I think we can check it out for sure. And then on the SCHC management draft, we need to probably also get educated about it and see how it would work as well. But thank you for the feedback. Thank you.
Okay, so yes, thank you very much for this work. I think it's very important to have this in the SCHC working group. So I have just a few questions to understand well. In slide 5, you make a structure, and you have things that is you have 2 positions. Does it work if you have 3 positions, or you have to define a new rule for that?
Sorry, I was muted. Yeah, it would work as well. I mean, in this example, we have the position because we have the 2 SNML record types, the humidity and temperature, but it would work. It would extend in the same way. If you have more.
Okay, and is it dedicated to JSON, or does it work with CBOR too?
I think the draft only mentions SNML and JSON at this point.
Okay.
But I mean, you can extend it, and I mean that's the thing. Like the question here, because with CBOR maps, you also do a bit of compression already. So how would you? I mean, like I guess you can do a CBOR map, compress with CBOR, and then apply the SCHC to it, right? That would be the order.
Okay. And finally, for in slide 7, I didn't understand for me, the feed will be more something like payload. And because here it's what you are pointing, it's all the data you are pointing, and TV can be the pattern, the template, that's good. But for me, I don't understand why you put application JSON NML in that. It's for me, it's more a place where it's more in the target value that it could be.
Right. This one I think is supposed to be the structure of data, not the. I mean, maybe the slide the date. So feed is the new structure of data as per the draft. I think maybe the slide is not accurate on this, but to be honest, I'm not, as I said at the beginning, I'm not super into every detail of SCHC, and probably this Lorenzo and Edgar can answer better.
Okay, because in ICMPv6 draft, we also compress the payload using a rule that already exists, because in a ping, for example, you have the packet in feedback, and so here we put ICMPv6 payload, and then we do things on IPv6 payload. So maybe we can have something also that ends on payloads.
Yes. Thank you for,
okay, thank you.
that. That's a good. Thank you.
So I see no other hands that are raised, but of course, I would also like to hear my co-chair and our AD what they're going to say about it. But like from experience and from what I'm seeing, it seems like a very useful draft. Right? So of course there are things to be clarified and things to be maybe changed a little bit, but this is when we get into the work, like working on the draft in a more active way. But for me, it's like there is a specific field of application, so SNML, and so there have been some works in the past, like on Seaboard templates as well. There was this thing that makes me think a little bit about like the static form of compression, but it's super useful. I mean, that was something that for me at least it's always been like, yeah, well, like it's something to do, right? I didn't actually know about the Dixie draft. Thank you very much, Alejandro, for that. I missed that, but maybe that's something that of course people could look at. But what I think it's really interesting is that here right now we have a draft, right? We have a draft that has been written, specified. So I find that to be really precious. So I'll be very happy to hear like what the other people in the working group think. But for me, that's something that we will be super interesting to have and to be that we have as a working group item. Yes, Alejandro.
Yeah, it was just to like make a point that there's some interest on it and that I've seen it. So so yeah, like if we have it in IETF, this would be good. Cool.
So Pascal, any opinion on?
Yes, my standpoint here is yes. I mean, the work is certainly interesting. I mean, the piece I was thinking about while we're talking was how this exchange of rules fits in the architecture. That's we have sometimes a tier party that provides the rules to both sides, and now we have a side which is the server which will push rules to the client, and in other cases would expect the client to know its flows and to probably provide the rules to the server as well. And in the PPP draft, we also have the case where there is some kind of trusted repository where a lot of rules are, and during the session setup, there is a link to wherever the rules are, which is passed so everybody can speak with the same rules. This tells me that there are all sorts of mechanisms by which both parties will end up syncing on a set of rules, and we must have the architecture open enough to that, so the rules are obtained but also trusted, because as you know, if there is an attack on the rules, then anything can happen.
Mm-hmm.
So yes, I mean,
Right.
doing this work is certainly interesting. It seems that the dynamic rules also extends SCHC a little bit in the direction of ROC. And now we'll know better, but wondering if we are taking SCHC beyond what we have done so far, which is very interesting. Yes, so all good on my standpoint.
Yes, I wanted just two mini observations. So one thing that I think it's super interesting, right? Here, when you're saying like the field ID, like the derived from keys, like application/JSON plus CNML.v.1. So probably here, if it's like a template compressed thing, so probably there could be like some kind of identification of the template. Like, I mean, if you have an identification of the template to be I don't know, like template 123 with some URN. So it can be like the URN could be put in this field identifier. So URN two dots, the URN slash, and then or application/JSON plus CNML v1, and then slash and the URN of the template. Right. And in this case, we know that, okay, well, we're talking about the first field of that's encrypted in this template. But that just like a
right. Yeah, I mean, we can look. I mean, for sure, we need to do changes on the draft, like the identifier. I mean, it can be derived from keys. It can be based on some URN structure, UUID, or other, other fields there to uniquely identify this. Yes, of course.
Yeah, and I mean, this goes to what Pascal said, right? It's because this way, let's say the compressor sees like it gets the SCHC context, and he says, oh, here I have a field ID and I need this template in order to understand the structure of this field ID. So then it can go fetch the template from someplace, right? Or the template can, of course, can be present in the SCHC context as well. But like we're already getting into a little bit in the work, and there's something I really loved. It's this one, right? So this is what Pascal says gets us closer to rock. But I don't think it's the intent, but it looks really beautiful to me. Like to say, okay, well, here is the couple of digits that change in the whole textual structure. So yeah, that seems to me to be like a very that could be super useful for SCHC. So Jaime, how do you see the next step for, and Edgar, of course, and how do you see the next steps for this draft?
Well, I mean, it'll be well. I guess first of all, we would need a bit more like a written feedback on this. Like, of course, it will be Git, and if people want to do a PR with changes, we will for sure check those. And then we need to look at it a bit on Dixie and on the SCHC core conf management, and probably Rock as well. At least me, maybe Edgar already knows this, luckily for us. And then, yeah, we will do another submission after that, and then it's up to the chairs and the working group to decide what to do with it. If you want to get it adopted, great. Although, I mean, yeah, the usual process basically. So far, the feedback seems positive, so that's great.
I think
Yes, perfect. Okay, so well, at least to me, it seems that's a very interesting document. So I hope that you're willing to continue working on it, and I'll be super happy to see some implementations like working on this document. And yeah, so thank you very much. Yes, Jaime.
I have a comment. There's a comment from Edgar, who's sitting here also. Like, just a second, please.
Maybe another thing we could focus is in the context provisioning. Check the coding mechanism that we have been written and see how we can use them here.
Right. So I don't know if the audio was clear enough, but basically the context provisioning is something we can focus on as well.
Okay, great, super interesting. So super interesting work. I think thank you very much, Jaime. Thank you, Edgar, and thank also to Lorenzo to taking the torch, taking the torch on this topic. Super interesting, and I hope that we get it. We work on it soon. Yes, so with this, I think it's time to switch to Sandra's presentation. So let me then just show the slides, and Sandra, I'm going to give you the control. So yes, the floor is yours.
Thank you. Can you hear me well?
Yes, it's good. Thank you.
Okay, thanks. Hello, everyone. So I'm presenting today on behalf of Rodrigo. He was supposed to come today, but he had an issue. So I'm a bit improvising here with the presentation. I hope I can answer all questions. So this is a draft we published a few weeks ago. It's SCHC over DTS IoT, which is direct to satellite IoT networks. So first, a little bit about the motivation. So we know that SCHC wasn't designed for networks prone to interruptions. There is another draft that we've been working with Edgar and Anna for defining the problems in delayed tolerant networks when using SCHC. But in this case, we are focusing on a particular DTN case, which is direct to satellite IoT. So what you see on the right is a figure that illustrates how when you have satellites coming and going, you have something called a visibility window in which you have connectivity toward the satellite. And then the satellite goes out of sight, and then you have a revisit window, and so on and so on. Now, there's another part of the connectivity that also is prone to interruptions, which is the satellite connecting to the ground station that will connect to the SCHC gateway. So in that case, you may also have interruption of connectivity because the satellite doesn't always have a ground station to connect to. So that creates a lot of challenges in terms of organizing the way in which the sender will use the visibility window to be effective, but also efficient, especially if we talk about constrained IoT nodes that are battery operated. So we have conducted a series of tests in which we see that the SCHC timers expire early because, of course, the sender doesn't know that the satellite is not available, so it transmits a lot of packets that are lost, and then that may result in a greater energy consumption at the constrained IoT nodes. So what we want to propose in this draft and discuss with the working group is to have a way in which the reliability mechanism in which we have confirmation of packet reception or fragments reception can be used in a more effective way so that we don't waste so much energy whenever we have interruptions in the communications toward the satellite and toward the SCHC gateway. So the idea here, and this is aligned with the new charter, is that we propose a type 2 hybrid ARQ FEC mechanism, which means using the confirmation mechanism plus forward error correction mechanism to allow the reconstruction of SCHC packets even if we don't have all the tiles or all the bytes that were originally sent. And this goes aligned with the charter in which we said that we were going to provide additional reliability mechanisms such as FEC for fragments. So the scope of the draft, I'm not gonna go in much details, but the draft right now explains the scenario first, and we explain all the problems that we have found when we have these interruptions during the connection to our satellite and from satellite to gateway. So that's the first part of the draft. And the second part is where we propose the ARQ FEC fragmentation sublayer. So the main idea is that we get the SCHC packet and then it goes through an encoder, and then we left the encoder to be implemented with any FEC code. So it could be Reed Solomon or whatever other encoder. And then after that, we have the fragmentation process, and the draft focuses on describing how to fragment that encoded packet. And then the same on the other side of the receiver. So we describe how the reassembly happens, when the receiver determines that the reassembly can happen, and then how to decode the packet to obtain the original SCHC packet. So this mode is using mostly SCHC at the end of the session in combination with the SCHC compound acknowledgement. And the reason to go for the SCHC at the end of the session also comes from some studies that Rodrigo particularly has conducted in determining which one is the less energy consuming process for these networks. So we've been using, for example, real visibility windows from LEO deployments from the Swarm constellation, which now belongs to Starlink. So using those visibility windows and sending different packets, we have determined that using the acknowledgement at the end of the session is the most efficient one in terms of energy consumption. So that's the one we'll be using here. And the main idea is that the receiver will at some point determine that we don't need to even wait to receive more bytes, because with what we have is enough to decode the packet, taking advantage of the FEC mechanism. So I guess what I want to highlight here is that we are not defining a specific forward error correction mechanism for this scenario. What we're doing in the draft is to defining the fragmentation process when that is combined with a FEC mechanism, and the way the behavior at the sender and the receiver to process those fragments, and the actions taken after we have received the fragments. Oh, sorry. So the idea was to, we're looking for feedback from the working group. We would like to hear your opinions. The draft is the first version of the draft, so it's still in early stages. Of course, we can still improve the descriptions, but we would like to hear from the working group, and looking at the future, maybe possibly getting the document adopted by the working group. Thank you.
Thank you very much, Sandra. A really interesting document. I don't know if there are any. Yes, please.
Yeah, sorry, I forgot to mention that we do provide at the end of the document examples of an implementation using Reed-Solomon. So we describe how the fragmentation happens in that case, and we also provide a second appendix with examples of how the mechanism, the entire mechanism, will work when we have no losses, when we have losses, and when we have different packet sizes. So we define the values that the attributes will take depending on the packet size and so on. So that if you can have a look at that, that'll also be great to hear back from the working group.
Thank you very much. So it seems to me that you have done a solid work with this satellite constellation in mind. Yeah, Pascal, do you have if you have a question, go ahead.
Yes, I'm just wondering, and it's for the group, not necessarily for Sandra alone. We had this document about FEC by Yorgos that you took over at some point, Alex, and it seems to me that we do want a document that explains how we can do FEC for fragments in SCHC. And now we have this document which uses that and has some is specialized for direct satellite. And I'm wondering if, we want one document, two documents. What happens to the one that you have, Alex, and how the two things fit together? Basically, that's my question.
Actually, it's a good question. Alejandro wanted to raise the hand. So I think that it's so the work can be quite complementary. In the work that we've done, we did not go as deeply in all these satellite related considerations, which seem to be addressed pretty in detail in this draft. So for me, there can be quite complementary approaches, right? And then as from, should there be two drafts? Probably the best thing will be if there's one that addresses both, right? Or if this draft is somehow integrated in the networks prone to delays, because I think there is the satellite part that is treated over there, right? So just a couple of directions for thought. And Alejandro, you wanted to say something?
Yes, just to participate in the discussion as well. So yeah, I also agree that we should work together and or like on a single draft. And then eventually, if there are adaptations to do with for certain technologies or applications that can go like based on the main FEC mechanism for SCHC, then okay, we can make certain adaptations or parameterize specific recommended parameters for specific technologies. So yeah, this on that side, and yeah, we're like not only for networks prone to losses, but also like on the aspect of reducing downlink, there's also an interest on this, I know. So yeah, it's definitely valuable, and we should pursue this direction as well, I think. I hope I didn't miss anything.
With Javier, when I asked the question, what I would really like to see is one document which is very technical on a mechanism which has fragment and FEC on fragments, like we did for the Akon error or something like that, and which is not specialized in the title to satellites or prone to losses or another use case. And then effectively one or more documents for one or more use cases, which, as you say, provide tuning parameters, whatever, on how we use the FEC mechanism for this use case. So ideally, we would define together, you guys would define together a mechanism for FEC that works for networks which are prone to disruptions, as well as networks which, like satellites, have windows, and that mechanism would work for all cases. And then you would spend more time in separate documents explaining exactly what the parameter is for satellites, as Sandra did, and how you tune or how you use the FEC and why you select it. For me, it's an applicability statement of the FEC mechanism to satellites or to networks which are prone to disruptions. That's more how I see it.
Yeah, I completely agree.
If I may, I think the way our current draft was described, it's, to be honest, is quite independent of the specific scenario of satellites, because the definition of how to handle the fragments to apply FEC and so on, it doesn't matter if the packets come from satellites or not. So I think the main part where we describe the behavior of sender and receiver could be easily taken to a more generic scenario, and then we can see what parts can be defined kind of as a profile for satellite, where we define the specific parameters for FEC and retransmission timers and so on for the specific case of the actual satellite IoT.
Oh, that's very nice. I would love to see this happen. And I'm a very strong supporter on having a FAQ document for SCHC fragments. That's really something that I will encourage as much as I can. So.
Yes. So previously we worked on a draft, so there's already some work on it. Of course, we took another direction, but that was precisely my concern, because me personally, I'm not a FEC expert. And then I'm also not an expert on, like layer 2 transmissions and so it was a bit hard for us to come up with this together. So yeah, I think we need to collaborate on this. And precisely the method, the method that you propose, it was something that we considered and that we thought would be a good solution as well. Like to have we called it like we defined it as a fragmentation layer. So to put it inside, so there's compression. So SCHC already has compression and decompression, and then there's the fragmentation functionality. So there will be like an independent, let's say, FEC functionality. So it aligns with what you presented. So yes, thank you very much.
Sorry, I haven't read the draft you mentioned forward error correction. that means that this can be added to the SCHC profile, that we can have this kind of functionality.
If I understand well, you're asking if the FEC could be added to a SCHC profile.
Yeah, that's what I asked.
Yeah, right now the way the document was written, it's this one is specifically for satellite IoT. But after what Pascal is suggesting, we may take the FEC plus ARQ description to a more generic document that could be eventually be used in a specific profile. So a profile could say, okay, the way the fragmentation works for this technology is with a FEC.
Okay, thank you.
Okay, well, that's really, I mean, that sounds super exciting, really. Thank you very much, Sandra, for and Rodrigo for bringing this document and for all the work. Yeah, it will be really great to work on converging the two documents and like starting to work together. And yeah, I think it's going to be a very, very, very good collaboration.
Alex, I don't see Bob. I mean, in the participants, so it might.
Yes, no, he is not here.
Well,
Well, I mean,
Hannah can give you a few news on the chats that we had. That's something
yes, please.
that
I mean, you're Anna. You go ahead.
well, I can give a few words and then Anna can correct me or something. My memory of the main points on the discussions was we were discussing about having requesting a UDP port. You know, that's something that some people wanted out of the draft. And then we discussed use cases with Carles, and Carles has a very interesting use case where basically we use SCHC as an alternate mechanism for 15.4, which means that basically we would signal that the packet is SCHC compressed by using a UDP port, and that port would go straight in the stack to decompression by a SCHC layer. So that port would be a well-known port, which would basically direct somewhere in the stack. Now, there was another use case where UDP port was in as, let me use it as a port 80 or something to open a request for a SCHC session. And then maybe the SCHC session itself would happen on a different port to free up this port or something. So basically, that could be where a daemon waits to establish a SCHC session or something. So just discussing that, it appeared that these were two very different use cases, and you could not even ask for a single UDP port for that. So at this point, it's still not obvious to me how many ports she could really need and for which use cases. I really like Carles' use case. I can accept the other use case where it's like where the daemon sits to establish the calls. Okay, why not? But the idea that we ask for one UDP port is already gone because these are two, right? I can't see the single port number doing those two different things. So it's not really a SCHC port now. It's an application that uses SCHC, and for that service or something, we want a port. It's related to SCHC. It's not the SCHC UDP port. So that's basically where our discussion was when we ended it last time. Anna, do you have other news that you want to share?
Hello. Yeah, I think that the other scenario was with connection, when we have a connection and we open a connection, so we need a port. We don't have any specific use case as the one for syslaw, but the idea is more for the flow protocols, the protocols that produce a flow, and how they can open a connection between two endpoints. And then to recognize that there is SCHC. The third point was how use the layer 4 ports as an identifier for the discriminator, for example, and how we can recognize that SCHC is used in an incoming packet. So we can use the layer 4 ports or the IP number for SCHC as an identifier. These are the 3 points that we were discussing with Bob the last time.
Okay, so I hope we
Thank you.
can do better next time and
Mhm.
converge at something. But for now, we have some ideas of scenarios, but it's not as well advanced as it is for ether type and IP protocols. So I don't know if it's still.
Pascal, just one
Yes.
question. So isn't it possible to have, like, if you use the UDP port, let's say we have only one UDP port for SCHC, right? And to define a basic SCHC packet structure. So, sorry, maybe it's not the exact term, right? Where we say, okay, well, if you're using this port, you need to have this kind of structure, like there needs to be a SCHC header, right? And it needs to be like this size, that there is this size of the rule ID, and basically something that can help you then to identify, okay, well, this is SCHC, and this is like for establishing a session, or this is SCHC and the session has already been established, and this is the session, and so it continues on the next instance, right? So something like RTP, you know, like on top of UDP, you have something else, and then you have the like the payload and so forth. If you see what I mean.
I mean, that's like you're talking about something like a dispatch type in 6LoWPAN, right?
Yes, exactly. Having something like this, that it's with a fixed structure, so you know, like even on like an intermediate entity, a router could look into and say, oh well, this is session establishment, so it's in this direction. It's not possible, right?
I guess we need to have a working session on this, but in one case you're in the stack and you just basically do something within the stack. In the other case, you're identifying a daemon. So for me, you are in two different worlds. But okay, let's have a more discussion on that. But I mean, at the point we are, if we ask for one port for this, we might as well ask another port for that. If we can really explain what it is and that, do they use SCHC? There are different things. But okay, let's have this discussion offline.
Yes, Laurent, you have a micro point for the minute that remains?
No, for me, I didn't follow the discussion, or the document. So for me, what is important is that when you receive a SCHC packet, you have to identify it. So at the UDP level, a UDP that contains a SCHC message, we need a port, and this port number is put into the discriminator. And the only risk, or the risk we have, is that if the port number is used by another application, then we can have confusions. So that's why it's good to have one port number for SCHC, because this way we will not have this kind of confusion.
Okay, thank you. So, well, yeah, I think, Pascal, you're right. We need to have another session. We'll talking a little bit more deeply in this, but from what I get, that there's a discussion to be made, right? It's not a clear cut.
Yes, and we have, as you said, only 1 minute. I just wanted to make sure we remind people that we have to produce an agenda by the end of this week for the Montreal meeting. And Alex, you have sent an email to the mailing list asking for items for this interim, but we also need to produce the agenda for Montreal. So we need to basically.
Are you sure it's are you sure it's for this one?
I was looking at the dates. Maybe I was too quick, but I thought that
draft working group agendas. It's for 22nd of October.
Oh, sorry, I was on the wrong page.
Yeah. No, I actually why I was so quick to react is because I also saw this like preliminary agenda is for Friday, but that is for the working group. That's for the scheduling of the working groups.
Oh, okay. I'm so sorry. Okay.
Yeah. No, I had the exact same thing. Like, oh, whoa, it's early, right? No, we have until 22nd of October.
Oh, okay, it's not the work group agenda. Oh, sorry, sorry for that.
Yeah, no problem. Okay. Yes, Anna, if you have like a mini word to say, and
yes, just because you are both there, and we need to publish again the architecture draft that is has the deadline. Yeah, is passed. So we need to work about the new version.
Yes, let's find a time sometimes next week. You're right, Anna. Okay, so everyone, thank you very much. Thank you, Eric. Thank you, everyone. Have a nice end of the day, and see you in 2 weeks. Bye.
Thank you all. Bye-bye.
Bye.
Bye. Thank you.
Bye.